This is question 24 on maths from section 2 of the 2019 BMAT. So we're told that a running track is in the shape of a regular pentagon and it's divided into these 5 legs, starting here and running clockwise. Now the bearing on the third leg is 110 degrees for the runner, and so we're asked, based on that, what is the bearing when running on the first leg? So where to begin here? Well, because this question is about angles, maybe we should think about the angles that we're going to be dealing with. And so a good place to start would be to work out the interior angles of this regular pentagon. If you don't know it already, we can quickly work it out by working out the sum of the interior angles. We can do that easily by dividing it into triangles and using the fact that the sum of interior angles in a triangle is always 180 degrees by the rule. And so we have 3 triangles, and so our sum of interior angles must be 3 times 180 degrees. 3 times 180 is 540. Therefore, what is each individual interior angle? Well, we have 5 of them, so 540 divided by 5, well, 500 divided by 5 is 100, 40 divided by 5 is 8, so the whole thing is 108. So we know each interior angle in this pentagon is 108 degrees, and so how can we use this to help us? Well, why don't we now think about what is actually meant by this bearing of 110 degrees. So a bearing is the angle between the direction that is being run and the direction of north. And so it doesn't matter where north is in this picture particularly, but we know the bearing is this angle away from a particular point, which is north. And so if you consider the bearing as we're running down this third leg, we need to think about how that would have changed from the original bearing on the first leg. So what angle is this bearing changing by each time we turn a corner of this pentagon? Well, is it actually this 108 degrees, or is it a different angle? So you can see as we go from 2 to 3, the amount we're actually changing the bearing isn't 108 degrees, it's an angle that's less than that. And in fact, it's the angle that arises from the difference between a full 180 degrees going down here and this 108 degrees angle here. So 180 minus 108 is 72. And this is what we call the turning angle in this problem. So each time we change direction and turn a corner, the bearing changes by 72 degrees. And we've derived that by working out the interior angle and subtracting that from 180 degrees. So let's now think about how we could work out our bearing on the first leg by using this turning angle of 72 degrees. So if we know our bearing was 110 degrees on the third leg, let's work backwards through the second leg and then back to the first leg. So what would the bearing have been on the second leg? Bearing in mind, we've turned by 72 degrees to get to 110 degrees. So if the angle increased by that much, let's subtract it from the 110. So the bearing on the second leg is 110 degrees minus 72 degrees, which is 38 degrees. Then let's keep working backwards to the first leg. So if we do the subtraction again, 38 degrees minus 72 degrees, that takes us to minus 34 degrees. Now, what's the problem here? We know angles can't be negative, and so we use the properties of a circle to work out the actual bearing. If we add 360 degrees to this, then this gives us a valid angle and a valid bearing. So let's subtract this 34 from 360 to get our bearing. 360 minus 34 is 326 degrees. So this is the angle from north that we were running at as we run up our first leg. So 326 degrees is our final answer, and this corresponds to H.